Alright, and welcome to Regressions Level 3, or aka our last actual math lesson of the semester. Now, what I want to talk about today is, it's kind of some current events. We're going to talk about how does COVID-19 grow, how should we have looked at the initial data, how has the data changed over time. And so I want to start with kind of a parallel example. In 2009, there was a worldwide pandemic due to a variation of the swine flu, which has a technical name of H1N1, which sounds a whole lot scarier than swine flu in my opinion. This actually originated in the US, and the table below shows the total number of cases over the first 18 days. There we go. Now, looking at this, what we want to do is we're going to really simplify these things, and we're going to write them as an exponential function. Now, here's the truth. An exponential function looks like this, and that's good when we're learning these things at a basic level. I want you to know the truth, though. The truth is that these things tend to actually follow what we call a logarithmic curve, okay? And it always appears that the first part of a logarithmic curve is exponential. So understand that whenever viruses grow, they're going to grow initially at an exponential rate, and then they're going to start to slow down. And why would the spread of a virus, why would it start to slow down? Well, people take active measures. People start wearing masks. People start wearing gloves. People start washing their hands more. We can implement lockdowns. We can implement social distancing. Also, sometimes over time, the viruses will mutate and become less deadly, or they'll become less transmissible. So, there's a whole variety of factors. Or even, let's say you have 100 people in a town and all 100 people catch it and then they're immune to it after they recover. Well, the virus can't spread to those 100 people again. So understand, there's a lot of various factors that will slow down the spread of a virus. What we're going to look at today is almost a purely theoretical kind of look at this, and we're only going to look at it over the first few days. Alright, once again, I'd like for you to take a photo of this table because we are going to go model this over in Desmos. So take a photo of that table and let's move on over. Okay, so here we are. We've gone to desmos.com/calculator, or if you want, you can just Google Desmos graphing calculator. And remember, you click this little plus sign, and when you do that, you just click table. Now, I've already filled in this table for you guys just because we really talked about filling in this table in our last video. Now, for this assignment, I only want you to run exponential regressions. It's not going to be exactly perfect, but it's going to be the closest thing we can do kind of at our level that we're at right now. So how do we run an exponential regression? Well, a couple things. I'm going to write out the general form first. Y equals A, B. And then once you put the B, you're going to push the shift button, and shift 6 will give you a little house top, and you'll click X. So Y equals AB to the X. This is an exponential general function. Now, how do we change it so we can actually utilize our graph? First things first, we're going to change this to Y1. The second thing is, a regression it's not an exact function, so we'll delete that. And I want y'all to push Shift, and if you look, it's going to be the button under your escape key up in the top left, and it's going to be that little tilde. So Shift tilde, and then we're going to go to our X1 value, and write X1. And so you'll notice that this line is a pretty good matchup for these points. It's a pretty good line of best fit. Some other things to look at, we can look at the R squared value. It says R squared equals 1. That would actually indicate this is a perfect fit. And then look right here, we have our A value and our B value. So remember, this is what we want to do. We want to copy down our A value and our B value. So I'm going to write those two things down right now. A equals 0.978, I'll go 3 digits, and B equals, 1.502. I'll also go out 3 digits. Okay, so once you have that A value and that B value, then we can go ahead and go back to our main video. Okay, so now here we are back to our original question. And so letter A said write an exponential function that best models the data. Well, I'm going to start with our general form, which is f of x is equal to ab to the x. It's actually very important to know that the b has to be inside its own parentheses. And let's go ahead and fill in our a value and our b value from what we just found. So it looks like our a value is 0.978. Okay, and it seems like our b value is 1.502. In fact, for time's sake, or space sake, I'm just going to write it like this. And so we have that. F of x equals 0.978, parentheses 1.5, raised up to the power of x. So this is the best function that models this exponential data. Now remember, this is only for the early stages of an outbreak. This won't hold true forever, but it will hold true initially. Now let's go ahead and talk about letter B. How many cases would you expect by day 22? So we're going to write f of 22, that's our input, is equal to 0.978 parentheses 1.5. And remember, this is where we plug in our x value, or in that exponent of 22, and we have a pretty simple thing to calculate. And you can go online, you can type in exponential calculators, whatever you have to do to find something, but 0.978 parentheses 1.5 raised up to the 22nd power will give us this number right here, 7,317.23. And I want you to think about this number. If on day number 1 we started out with one case, by day number 22 we have 7,317 cases, we could say that this grows very, very quickly. And in fact, I believe in the first year of the H1N1 pandemic, could be wrong here, but the article that I read said that over 60 million people were infected. So H1N1 was a very, very contagious flu. Now, where's this one different from the coronavirus, COVID-19, is that the 2009 swine flu had a much, much, much lower death rate. So a lot of people caught it, but a lot of people didn't experience as powerful ill effects as they do from this current coronavirus. Now, this video and the information in this video will allow you to answer all the rest of the questions. It is going to be the only video for this assignment. So why do I want you to undergo this assignment? I just want you to have a better understanding of what exactly is going on. I want you to have an understanding of, like, how did the cases grow? I want you to have an understanding of how can our data be interpreted, and how could our data be maybe initially wrong or maybe grow initially better. So give this assignment your absolute best effort. Like I said, this is the last one that we'll do for the entire year. I'll do one more that's kind of like a survey just in my class in general. But good luck, and yeah, guys, I really appreciated teaching you this year. I hope y'all have a great summer. All right, thank you all. Bye.